Welcome to our YouTube channel, Local Teachers. Today we are going to discuss image formation and derivation of curved surface formula. So here image formation is nothing but here. We know that when two reflected rays meet at a particular point, at that particular point only image will form. Okay, here, so what is the second one? Derivation of curved surface formula. So that is nothing but here we are going to bring a relation between, a mathematical relation between object distance and image distance as well as refractive indices. Okay, so for that here we are considering a curved surface which is separating two mediums. Those refractive indices are N1 and N2. So I will represent that in diagram. So here I am considering, so this is a curved surface. So one side I am considering water is as one media, and another side I am considering air as another medium. So its refractive index of air is N1 and the refractive index of air is N2 I considered. So here, so the midpoint of this curved surface is P. Okay, so here the line which is passing through P and C is nothing but principal axis. Principal axis. So here at, at a distance on principal axis, I am considering a point object, so that is O. So in order to form the image, I require two refractive rays. For that, I require two incident rays. So from this object, I am considering two incident rays. The first incident ray is follows along the principal axis. So here we know that the incident ray which follows along the principal axis does not deviate when enter from one medium to another medium. Next, I am considering second incident ray from the object making an angle with alpha with respect to principal axis S. So here the second incident ray making an angle alpha with this principal axis. So it will incident on the curved surface at point A. Okay, so these are the two incident rays. So here I am drawing a normal from the point incident point to a line to center of curvature, so which represents, so it is a normal line. Yes. So here the incident angle I consider this is theta 1. Okay, so I am drawing the refractive ray for this incident ray 2. So after incident it will move like this and it reaches to principal axis at a point. See here, so this point is I considered I. So see here, this is the first refractive ray P and I, and this is a second refractive ray, so A and I. So these refractive rays are reflected or meet at point I. So here the image will form. So here form the image. So this is object. Okay, so here the refractive angle I considered theta 2. Okay, next here I considered the second refractive ray making an angle with this principal axis is gamma. Next, I considered this normal is making an angle at C with respect to principal axis is beta. So here I am drawing a perpendicular line from point A to principal axis. So this perpendicular line will meet this principal axis at a point. That point I denoted with N. Okay. So here, so this is regarding I considered an object O and it forms image at I. Okay. So for this clear analysis, in order to find the derivation curve surface formula or in order to bring the relations between V, U and N. So here I am considering triangle, consider triangle A, C, O. So in this I can write here for this triangle angle theta 1 equals to alpha plus beta. So this is nothing but here simply I can explain. I will explain here. So this is the triangle which I considered. So this is A, C, O. So this is alpha and this is beta. So this is the angle theta 1. So on the triangle properties, the external angle theta 1 is equals to the sum of the opposite internal angle. So on that basis, I was written this theta 1 equals to alpha plus beta. Next, consider triangle A I C A I C. So in this beta equals to the external angle beta equals to sum of opposite internal angle. So here beta equals to gamma plus theta 2. So this can be written as theta 2 equals to beta minus gamma. So consider this is equation 1. Consider this is equation 1. So here for figure so according to Snell's law we can write n1 sin theta 1 equals to n2 sin theta 2. So consider this is equation number 2. Okay. So here substitute equation 1 in equation 2. So therefore we can write n1 sin alpha plus beta equals to n2 sin beta minus gamma. Okay. So consider, so this is equation 3. Okay. So for this figure here, if considered paraxial rays. So what is meant by paraxial rays? So paraxial rays is nothing but the rays, the incident rays which are traveling in parallel with the principal axis. So the parallel rays which are very near to the principal axis. So here paraxial means these are the parallel rays, but these are very near to the principal axis. So if I consider like that, so alpha, beta, gamma angles are decreased. Angles are decreased. ఎందుకు డిక్రీజ్ అవుతుంది చూడండి, ప్యారలల్ రే అంటే ఇలా తీసుకోవచ్చు దగ్గరగా. So like this. So ultimately if I draw like this, so this angle alpha will decreases, so beta will decreases and gamma will decreases. So I can write here this sin alpha plus beta equals to alpha plus beta, comma sin beta minus gamma equals to beta minus gamma. Therefore I can write equation 3 as n1 into alpha plus beta. Why? Because this value will become here alpha plus beta, that equals to n2. This sin beta minus gamma will become here beta minus gamma. Just multiply here n1 alpha plus n1 beta equals to n2 beta minus n2 gamma. So in this which is common? So beta is common. So bring same side beta. So I can write n1 alpha plus n2 gamma, that equals to n2 beta minus n1 beta. So I can write n1 alpha plus n2 gamma equals to, take beta common, so that is n2 minus n1. So consider this is equation number 4. This is equation number 4. Here I consider paraxial rays. Okay, so that what happens here? All the angles are became very small. So I can write here tan alpha equals to, so here tan alpha is nothing but I am going to apply here, this is alpha, so I am applying here tan alpha. So for which triangle here I am applying this triangle OAN. So in this applying tan alpha, so it will become AN by NO. Next, so that equals to, it will become alpha. Next, tan beta. So tan beta is nothing but here. So it is applied for triangle ANC. So I can write here, so tan beta equals to AN by NC. So the opposite by adjacent. So this can be written as beta. Next, so tan gamma equals to tan gamma. So this is the triangle. So this applied for triangle AIC. So that equals to opposite. So that is nothing but A. So I am considering triangle AIN I am considering. So I can write tan gamma equals to opposite AN by adjacent NI that equals to gamma. So here consider this 3 is as tan alpha, tan beta, tan gamma. The values are considered equation 5. Substitute equation 5. Substitute equation 5 in equation 4. So I can write here n1 into, so what is alpha value here? An by NO plus N2, gamma is nothing but An by Ni, that equals to beta. So what is beta? An by Nc. An by Nc. So here An by, this is Ni. Ni equals to N2 minus N1. So here An is common for left hand side as well as right hand side. Just I will cancel this An. I can write N1 by NO plus N2 by Ni, that equals to N2 minus N1 by Nc. So consider that is equation 6. So at this instant, if I considered very closer incident rays parallel to principal axis, here N will meet at point P only. That means, so this N will become P only. So I can write this NO equals to PO, Ni equals to Pi, next Nc equals to Pc. Okay. Next here I will try to find this PO value and Pi value and Ec value from the diagram. So look at the diagram here, PO, so PO, the distance of object. Next, Pi, the distance of image. Next here, PC, so this is radius. So here, for finding this values, apply sign convention. So by applying sign convention, so we can write these values. So always the distances will measured from the pole only, from the midpoint of the curved surface only. So if it is measured in the direction of incident ray, so here it is in the direction of the incident ray. So in this direction, if we measure the distance, so that is positive. So if we measure in this direction, the distance is negative. So here, observe here, we are going to measure first one PO. So the incident ray is in this direction, we are measuring the distance in this direction. So it will give negative. So what we are going to write now? So the distance of PO equals to U. Applying sign convention, it becomes minus U. So next go for Pi. So Pi is nothing but here is P, here is I. So we are measuring the distances in this direction. So both are in same direction. So it will becomes positive plus V. Next, go for PC. So that is equals to plus R. So we got these three parameters. So just substitute these parameters in equation 6. So we can write this equation 6 substituting the values. So N1 by minus U equals to sorry plus N2 by Pi is nothing but plus V that equals to N2 minus N1 by plus R. So I can write this equation in a perfect manner. So that is N2 by V minus N1 by U that equals to N2 minus N1 by R. So this is the derivation. This is the derivation of curved surface formula. So finally I got that equation N2 by V minus N1 by U equals to N2 minus N1 by R. So this is regarding this derivation. Okay, so this derivation is very simple. Just I will repeat in least time. So this is regarding this diagram. So here first I find out that theta 1 equals to alpha plus beta. Next I find by considering triangle AIC. So that beta equals to gamma plus theta 2. I got here theta 2 equals to beta minus gamma. Next come here. So here I applied Snell's law. So that is N1 sin theta 1 equals to N2 sin theta 2. So I got the theta values. I substituted here the theta values. I got here the equation N1 sin alpha plus beta equals to N2 sin beta minus gamma. Okay, next here I considered paraxial rays. Paraxial rays is nothing but these are the rays in parallel with the principal axis, but it is very near to the principal axis. So here, if I consider the rays like this, so ultimately alpha value decreases. So here beta value decreases and here gamma value decreases. So that I was written here, this alpha, beta, gamma angles are decreased. As the angles value is decreased, ultimate what happens here, sin alpha plus beta will becomes alpha plus beta, sin beta minus gamma will becomes beta minus gamma. So I substituted the value, I got here N1 alpha plus beta equals to N2 beta minus gamma. So I expanded that. So I got here finally N1 alpha plus N2 gamma equals to beta into N2 minus N1. So here when I consider these paraxial rays, ultimately what happens here, all the angles are become very small or reduced. So here I can write here tan alpha equals to, so because here I want to find the sides, so I want to bring the relationship between u, v and n, r. So that is nothing but here I need sides, so that what happened here, I written here tan alpha equals to an by no, sin beta equals to an by nc, sin gamma, tan gamma equals to an by ni. So considering three triangles, I got the alpha, beta, gamma values. Just that sides are substituted in the previous equation. I got this equation. So here, so that equation is written n1 by no plus n2 by ni, that equals to n2 minus n1 by nc. So here I want to find the values of these. So here I am considered paraxial rays which is very closer to the principal axis. So ultimately this n reaches to P only. So I can write instead of n I can write P. So I was written here NO equals to PO and NI equals to PI, NC equals to PC. So here by applying sign convention I got the image distance, object distance and R value. So here I got here minus U plus V plus R. I substituted the values and I finally got the equation N2 by V minus n1 by u equals to n2 minus n1 by r. So this is curved surface formula uh, for curved surfaces only. So this can be applied. This can be applied for this plane surfaces only. So here the difference is nothing but here. So the if we consider this equation for plane surfaces, so this r will become infinity. So r will become infinity is nothing but something by r, n2 minus n1 by r. So r is infinity, so this right hand side will become 0. So finally we got here n2 by v minus n1 by u equals to 0. So for plane mirrors, n2 by v equals to n1 by u only. The difference is just r will becomes infinity. So right hand side will becomes 0. So this is the story behind this image formation and derivation of curved surface formula.